quite a bit of research has been done by a gentleman by the name of Jay Geed, and he runs these great studies, and he looks at twins, and he looks at all sorts of factors. But he's talking about at age 11 in girls and at about 12 in boys, the brain's ready for the pruning. And so it's a really key development time for our teens. And so we need to think about that. What gets pruned away, as we talked about last time, is pathways that aren't being used, areas that aren't being targeted. And it doesn't mean we need to go crazy so our kids never lose any of their pathways, but it does mean that, you know, if a child is sitting on a couch all night playing Nintendo or whatever, those pathways are really strong, and the other pathways in the brain won't be as necessary, and so they'll be pruned away. And so they've also linked that to some things like Asperger's and other kinds of challenges that kids have in terms of how that pruning happens. The other interesting thing, along with the pruning that's going on through adolescence, is something called myelination. And myelination, I'm not sure if you're familiar, but there's this sort of white covering called a myelin sheath that sort of goes over our brain cells. And it starts at the base, at the back of our neck, and kind of works its way up. And it's much like a cord, an electrical cord, that has that plastic covering over it. And so when you think of that and electricity, well, what does that do? It makes it go faster and straight to where it needs to go. And so this process of myelination is happening in our adolescent brain. And it's starting, as I said, at the back and kind of working its way up. There are some spurts in the temporal lobes and the parietal lobe between the ages of 6 and 12. So that's just interesting to know. Spurts of this myelination process. And these are areas that specialize in spatial, sensory, auditory, and language functions. So there's a real neat window for kids to start to learn languages, right? And then it gets a bit trickier, and as an adult, it's even more trickier. So that's part of what goes on there. But then for the adult, or for the child coming up to about age 20, that myelination is continuing and working again quite a bit in the prefrontal cortex. So what are the implications for this? We've talked about some of the mysteries, and I think some of what we focus on now in terms of the implications will touch on that. So some of the things that start to happen as our adolescents are experiencing the growth of these pathways and the pruning and the myelination is the emotions, reading facial expressions, and also taking risks. So that's only a few, but those are things that I thought it would be interesting to kind of focus on. Some of the research refers, it's a bit older research, to the triune brain. So instead of a very detailed picture as I've given you, it just kind of puts pieces together. But it makes sense in a way. As I said at the beginning, the goal of our brain is survival. And so at that center core is the survival brain, or the reptilian brain it's called. It's like the brain of a turtle, and it's the part of our brain that says fight or flight. It's the part of our brain that keeps our body systems going. It's the survival part of our brain. The hypothalamus is in there, and we'll talk about that in a minute, but that's where the survival part comes from. The second part of our brain, a little further out, is the limbic system, which also encompasses that reptilian part, and it is more about the emotional, looks for cues of danger. Emotions are triggered. It helps us store some of our important events in long-term memory. And the outside part, they're calling it neocortex here. A lot of the reading would call it a prefrontal cortex as well. It's the thinking part of our brain. It's the logical part of our brain. It's the part that says, if this, then this. And the actual sort of pruning and myelination, all that stuff takes place there last. And so you end up seeing a great deal of information passing from the emotional brain to the reptilian brain. And you see a good deal of information passing from the emotional brain to the thinking, or the neocortex. But you can see that there's quite a bit less information coming from that prefrontal cortex. And we're going to talk about that and what the implications of that are. Again, Kathy Nunley does a very simplistic diagram for us. But what we're looking at there is the limbic system. It's the encasement of the emotional part of our brain, as we might see it in our teenager. And you can see the thalamus up there, and it's not, the thalamus isn't the thing that makes the news. Its job is to sort sensory data as it comes in. And so if you see a beautiful flower, the thalamus takes that and it sends it to the visual cortex, the visual part of your brain, and your brain registers, I see a beautiful flower. But what would happen if your thalamus wasn't working? And instead of sending it to the visual part of your brain, it sent it to the auditory, the hearing part of the brain. And now you hear a beautiful flower. We call that hallucinations. And that can be tied to schizophrenia. It can also be tied to hallucinogenic drugs. So that's when things start to get a bit mucky in terms of how we're interpreting things that way, sensory, with our sensory, that is to do with the thalamus. Down below that is the hypothalamus, and that is our survival part of our brain, as I've mentioned. It's the most primitive part of the brain that can drive behavior. It's almost I think it's the only part of the brain that's fully formed at birth. So interesting, right? Because we're built to survive. And again, as I've said before, it controls fear and anger and aggression and those primary kinds of emotions. And it's also responsible for the fight or flight, hunger, thirst, sex drive, body temperature. Those sorts of things rest in the hypothalamus. The hypothalamus, as you'll notice from that diagram, is strongly linked to the amygdala. And that's a small sort of almond-shaped part of our brain that's responsible for some of the more subtle emotions that we have. Things like jealousy, love, compassion, kindness. The amygdala develops over time, usually in childhood, and often based on the environment. So we've got the hypothalamus, which is our sort of fight or flight survival part, and then we've got the amygdala that is developed over time. Let me give you an example of how that might happen. I don't know if any of you had this experience, but you might have been a little girl, some of you might have been a little girl, who wanted a beautiful doll for your birthday. And so maybe you're 5 years old and it's your birthday, and there's a little party for you, and lo and behold, mom and dad give you this prized doll that you've waited your whole life for. And you gather it up and you love it and you hold on to it, and then gradually your attention wanders and you set that doll down. In walks your 3-year-old brother, who notices the doll and thinks that looks like pretty fair game. And so while you're off doing something with your friends, he's got crayon and he's coloring on it and he's putting plasticine in the hair, whatever he's doing. So when you return from whatever you're doing to scoop up this beloved doll, in that moment, when you look at that doll and you look at your little brother with the little look on his face, I don't need therapy for this, honest. In that moment, it's your hypothalamus reaction, right? What do you want to do to your little brother as that little kid? What do you want to do? Yeah, I hit him with the doll. Like, you want to kill him, right? He's like, ugh. And in that moment walks mom, who says, it's okay. He's only little. We can fix this doll up and make it as good as new. It will be fine. Give him a hug and let's go and have our birthday cake, right? And those moments over time in your childhood actually develop your amygdala, part of your brain. As you've had that modeled and as you've had that talked to, that's the part that is developed through experience and through observation. And if you're fortunate, you had many of those experiences in your childhood so that when you get to be a teenager and older, you can do that on your own moderation, right? You don't need your mom to come and say, really, we need to move along. So that's sort of how the amygdala is developed. And we can call those amygdala moments. They still happen with our kids now. I forgot to say when I was asking all of you how many kids I have 3 kids with adolescent brains, 18, 20, and 14. So I'm just wanting you to know that because we can still continue to work with our kids and help them to have these sort of amygdala developing moments. Just a second, that's making you really angry. Let's talk it through. Let's see if there's another way to look at it. And it's the amygdala that will develop those sort of subtle responses. So the hypothalamus ensures our survival. It asks sort of one of 3 survival questions. Should I eat it? Should I mate with it? Should I run from it? I mean, those are sort of the basic hypothalamus questions. And the amygdala is the one that's trying to sort of soften that and provide those more subtle emotions. But who does the hypothalamus ask that question to? Really, that question's being asked to the higher part of the brain, the higher thinking part of the brain, which is the prefrontal cortex. And so we'll get to that in just a minute. What I want you to remember about the hypothalamus is it's very active in our adolescent lives. It's active because the hormones associated with puberty excite or increase activity in the hypothalamus. And it's active because it's influenced by behaviors around it. And what typically do teenagers do but surround themselves with other teenagers? In which case you've got just this big pool of hypothalamuses all joining together and sort of modeling and learning from one another. And the last part, or the last reason why it's good to have, is that the prefrontal cortex, which we're going to talk about now, takes until our early 20s to mature. So that's sort of how the amygdala and the hypothalamus work. And the last piece is the prefrontal cortex. And in the handout that you have, it talks about that prefrontal cortex as being kind of the CEO of the brain, the sober second thought, the place of reason. And that, the research is saying now that that is taking well into our 20s before it's fully mature. So when the hypothalamus is saying, do I eat it, do I, run from it, do I mate with it, it's asking that of the higher level thinking part of the brain. And I know the questions are a little more complex than that, but those are the themes that reside in the hypothalamus. And all of us have this experience of that wrestling of two voices in our heads in a way. We're seeing Jekyll and Hyde this week. We remember Flintstone with the two little guys on his shoulder, right, one on each side. And it's that voice that sort of goes back and forth. So maybe some of you have had this experience. You start a diet on Monday morning and you're feeling really great, and then you go into work, into the staff room, into whatever. There's an amazing cheesecake. It's somebody's birthday. And so immediately you're like, oh, I want a big piece of cheesecake. And that's your hypothalamus, right? I want to eat it. Yes, a big piece would be great. It's asking the prefrontal cortex, can I have that? And the prefrontal cortex is saying, you don't want that. You've been good for 3 hours. You can hang on for the rest of the day. And the prefrontal cortex is saying, imagine how much time you have to spend on the treadmill if you eat that piece of cheesecake. And so the prefrontal cortex kind of consults history and data and reason and lays it all out. But we don't necessarily have to listen. And you may have had this experience where you turn around 20 minutes later and that cheesecake's gone. It was great, right? We didn't have to listen. And that is the same kind of process that goes on sometimes for our kids. The prefrontal cortex is the part of our brain that allows us to see the future. Somebody said that one of the mysteries is short-term thinking. And that's because our prefrontal cortex is taking a while to develop. It's taking a while to catch up with the rest of our body and our being. We, as adults, have had experiences where you're driving along and somebody just mindlessly cuts you off. What's your reaction? Or you wake up on a beautiful spring morning and you think, gosh, I'd love to go golfing. I'd love to just call in sick and go golfing, or whatever it is you love to do on a beautiful spring day. And we don't do those things, most of us, very often, because we have this voice of reason that says all the logical things that would tell us it's probably not in our best interest to do that. That's the part that's being built for our kids. The prefrontal cortex sets out the reasoned arguments about why things make sense. And it's interesting, the research starts talking about adolescence as being able to develop some inhibiting behavior. And I think we heard a little bit about that over there too, just that impulsivity and control. And that inhibiting behavior is coming out of an understanding of the future, an understanding of if this, then what. Our kids don't understand long-term stuff. You raised that. So if we're going to say, working really hard in school when the child's in, grade 7 or 8 or 9 or even 11 or 12, you're going to be set up for life. You're going to have a great life. You'll go to school and you go to university and you'll be really successful. That's a bit long-term for these kids because they don't have that in their brain. We want to talk to them about the richness that the learning provides and the good experience that will give us now, and how being in this team or participating in this thing, what are the things that will happen right now for us that will be great as a result of that? That's kind of where their brains are at. We can tell them the long-term stuff too, because we will. But we also have to understand that it may not resonate as strongly as if we do the other.